use this simple example to show you how support reactions could help us or could guide us in drawing shear and moment diagram. To do so, first you need to know what type of reactions each supports are producing. So at point A, we have a roller type of support, and you know that a roller is able to just provide one support which is perpendicular to the surface of that support. At B, we have a pin type of support, and pin produces two type of support reactions, which are By and Bx. I draw very quickly this beam on top of these two supports, and I'm going to show this external force that I have, which is 10. Now, by examining this beam, you can see there is no horizontal force. That means that Bx is equal to 0. But we have a 10 force perpendicular to this beam, and if you write sigma Fy is 0 and sigma M is 0, because this is simple, I'm not going to write it. I just directly write that Ay is equal to 5 and By is equal to 5, because 10 is in the middle and the force will be divided in between these two supports. Now, one last thing is, we know that this type of support, or these two types of supports, are not able to provide any support in terms of or against moment. That means that Ma is equal to Mb, and that is 0. Look, whatever I draw in here is FBD, free body diagram, which is step 1 that you need to take. You need to draw first FBD in order to find support reactions. But I'm trying to use these support reactions to draw my shear and moment diagram. I realize that MA and MB is 0. Therefore, I go very quickly on moment diagram and just I show that moment at A and moment at B is 0. I will get back to this moment diagram later, but I just wrote the magnitude of moment that I have at A and B, and I leave it there for now. Now, in order to draw a shear or moment diagram, you need to use the sections method. So I'm drawing a section on the left side of this 10 kip, slightly to the left side of that 10 kip, and I need to draw FBD for this section. So I have 5 at point A. I don't have any other force in here, and I have V. I use V1 to show it, and you know that based on positive sign direction, if I show them in here, on the right side V is positive upwards, so this is our positive V, and on the left side V is positive downwards. To explain this, assume that your right hand, when you want to cut this or shear this, your right hand goes up and your left hand goes down. Therefore, on the right side positive is upwards, on the left side positive is downwards. So this V here is positive downwards. Now I can write sigma Phi is 0. That means that 5 minus V1 is 0. That means that V1 is equal to 5 kip. So I calculated AY and it was 5. I calculated V1 and it's 5. That means that support reaction is equal to V at support, or V is equal to support reaction that you calculated. V is equal to the support reaction that you calculated. But you need to pay attention to the sign of that V. So we will draw for B also to see for B is positive or negative. for now, we know that at point A, V is equal to support reaction, and it's positive because I don't have any other forces all the way till 10 kip. So it means that this 5 goes all the way till 10. Then you can see that 10 is pushing me down 10 kip. So I have 5 in here. That means that I need to go all the way down to another 5. So I have a 5 in here and another 5 in here, and totally it's 10. So I go down all the way to negative 5, and again I don't have any other force. It goes all the way to the end of the beam, which is point B, and at point B magnitude is 5, but the direction is negative, the sign is negative. So let's examine it. Let's draw FBD this time on the here on the left side of B and see why it is negative. So I draw FBD for the section. I have B, which is BY, which is 5 in here, and I have a V, and it's looking upwards, based on the positive sign direction, so it's looking upwards. So if I write sigma Fy is 0, that means that V plus 5 is 0, and from there V is negative 5. Well, so it shows that at supports, V is equal to the magnitude of support that you calculated, but you have to pay attention to the sign of it. It could be positive, it could be negative, but at least you know that the magnitude is equal to whatever you calculate. So you can draw FBD for this, draw shear diagram for this beam and say that V is negative 7, for example, or positive 7 at B. It's equal to support reaction that you calculated. Let's go to M, and M is going to be something very similar. We learned that M is 0 at support, at both supports. Therefore, we just need to find M at any point in the middle, and the rest is going to be very simple. Let's use this FBD that we have in here. So I just draw M in here, and I'm writing down. So sigma M is 0, then 5 times, because this distance is 5 feet, times 5 feet minus M is 0. From there, M is 5 times 5, 25 kips feet. So it means that at this middle, it goes from 0 to 25, and because I know that M is 0 at the end, that's very simple. I just can draw a line and join these two guys to each other.